So this one says determine the appropriate trig sub. So I love these kind of little problems. It doesn't say to evaluate the integral, right? So this one might be the one you're talking about. I don't know. Yes? Okay. So, do you all have a feel for what you have to consider when you're trying to pick which trig? Can somebody give me an idea? Just what could a trig sub look like? Just give me one. X equals what? Just in general, don't even look at that. Just look at me. X equals? No. There's specific ones. Yes? I'll start us off, okay? It could be x equals sine theta. Or so it could be x equals 3 sine theta. It could be x equals 7 sine theta. It could be x equals 2 over 5 sine theta. Yes? What else? What else could it be? No? I love you guys. Okay, this is concerning. So, it could be sine. It could be tangent. Or it could be secant. There you go. Those are the three big ones. And it has to do with the output of inverse trig related to those as to why we choose, for example, sine, not cosine. So technically, a cosine trig sub would work. But one immediate thing is, wouldn't the dx have a negative that you'd have to always take care of? Do you see what I'm saying? So there's a bit of a reasoning behind why we use these big three, right? And again, so what thing you have to desperately realize is you are not just sitting there saying, all right, I guess I got to try all three of these things. My God, that's such a waste of time. So what is it about a problem that tells me which one of these is going to work? Which Pythagorean identity it relates to. So one Pythagorean identity would be like 1 minus sine squared is cosine squared. A length, right? So if I see a number minus something x squared, that kind of thing, that's telling me to make it sine. Because the trig function would go here, the constant I can make 1, or I could pick the appropriate coefficient. You guys semi with me? Okay, and I try to make a big deal out of this because if you're not careful the way you teach this, you guys as students, you're like, I just hope I pick the right one. Or you're like, any of them will work. Yay! No. They have to match their identities or else you can't go anywhere with them, right? So which identity relates to this? Yeah, because what's secant's identity? Secant squared? No. Minus 1 equals tan squared. Because tan squared plus 1 equals secant squared, right? So if I see function minus number, that's secant, right? Okay, and again, constants, you got to take care of them. That's going to tell you what A is, but I don't give a shit. Those are just numbers. Numbers normally are not a big deal. We can make those work. It's the functional part of things that freak us out. Constants I can take care of, no problem. You guys understand? So, right here, we've got trig squared minus number, that's secant. So what is A? So I know it's x equals something secant theta. So how do I always figure out what that something is going to be? Square root 2, I love it. And if you think ahead, if you square it, that is going to become 2, that's going to match with that 2, and you're able to take a 2 out of the way, and the Pythagorean theorem is, the Pythagorean identity is sitting there staring you in the face, right? Maybe? It's always good to understand the logic behind a process. Don't just memorize the damn process, right? If you don't understand why a process works or what the thinking was behind it, ask that question. Because that's huge. Otherwise, you're just going to be lost on every single problem and just go, you roll the die, roll a D3. Okay, no D&D people? Okay. All That has to be okay, because that's the only thing the problem wanted from you, is just which trig sub would work. You don't have to actually do that problem. Okay. So let me ask you this. What if, this is number 3, right? 7.3, is that right? Is that where we're at? Yeah. What if I had this? This is my own example. What if I had integral x over, let's make this 1 over the square root of 16x squared minus 49. Sort of, except what's kind of wrong here? The number in front of x squared is not 1. So you have to be a little more careful. So there's 2 ways to go about this, right? The most direct way to do this, what you got?
I was gonna say 7 secant 4.
I like it. You got the right numbers in there, just in the wrong place. So how do you make a 1 show up here? What do you have to do? Take out a 16. Let's take out a rad 16, which is 4, yes? So then what's going to, if I divide by 16, what do I get on the inside? I'll do this one. All right. So it's going to be another secant thing, right? But now it's going to be what secant? What is square root of 4 now? 7 over 4. So, and the right number is just wrong place. Yeah. Do you guys see that? Yeah. Anytime there's not a 1 where I want it to be, we can make that happen. Again, numbers don't give us any problem. We can get those out of the way. We can, we can do all kinds of shit with them. Functional parts, damn it, can't do much with those. Okay, maybe. Is that better? I don't know. Is that better? It's that same point I'm trying to make. The more you know the Pythagorean identities, the easier trig sub is. Because there's no guessing. It's just that the way it's written, it tells you which thing to do, right? Okay, maybe? Yes? Sorry? What about if I had, what do you got, Jeff? Oh, yeah, sure, why not? Yeah. Are you excited about that problem?
No.
Is the problem hard? No, the problem's easy as shit. It's just as easy as that one was. Right? Just uglier numbers, who cares? Who cares about numbers? Right? Poor little numbers, I care about them, but who cares about them? They're not going to get in our way. What's the very first thing I have to take care of?
2.
Yeah. I'm going to take a rad 2 out. And what's left inside of it? Divide by 2. All right, so what's the appropriate trig sub, considering the identity? Tangent. And what's going to be in front of the tangent? Nothing you want, but who cares? Rad 11 over 2. That looks gross, doesn't it? Who cares? It's just a number. It's just going to come for the ride. You kind of see what I'm saying? And I don't mean to make you feel bad if you're like, oh my God, it's going to make it so. I'm trying to make you understand. It's just a number. It's just going to come for the ride. You just got to not forget it, right? So this is rad 11 over rad 2, or you just make it one big S. Yeah. Okay. Again, not what you would prefer, but who cares? The process of figuring out what goes there is always the same. That's the point. I don't care what the numbers are. Okay. Is that better or worse? Did I just make things worse? You're like, I understood it better before you said anything today, Jeff. Damn it. All right. That has happened before, and I was like, ugh. Anything else on that or something else? Yes?
Problem number 9 on 7.3. So is it evaluate the integral by then specified to do like trig sub? So I did use sub. Is that okay?
Yeah. Yeah. If they don't say, then just do it. Whatever works. Yeah. If they don't say in the directions. So on my quiz or test, you're going to see me say, like I did on the quiz, use this method. on this one, yes? And I have to say that because if I didn't, you might be able to find all these other methods and I never test you on a certain method. Does that make sense? In the homework, yeah, if they don't say that, you can use anything you know up to that point. Now, one thing you have to be careful about, if you get behind in the homework and we learn something new and you use something from 7.4 in 7.2, when you do a homework, you have to put yourself in the place of what you knew then. That's all you can use. You can't use something you learned later. Does that make sense? Okay. That's why it's hard to be a tutor sometimes, because they try to show L'Hopital's rule to calc students way before they learn derivatives. They're doing limits, and they're like, here's L'Hopital's rule. What's that? I don't care. Just do it. Like, no, I know it's easy, but they don't know it yet. You got to live where they are, right? Okay. Remember the hospital man. Remember L'Hopital's rule? Okay. Poor L'Hopital. Sure, I'm the hospital man. All right. Anything else from homework stuff? Because I agree with you. That's totally U sub, right? No reason to make it all triggy. All triggy, Jeff? Did you really just say? Okay. Yeah, but there are several in that section you have to use trig sub on, so that's fine. I'm all for doing it the easiest way as possible, as long as it's something you're allowed to use. Yeah. Okay. I think there's no other. Yes.
So I just had a question on a definite integral question. It was a arctangent of 1 over x dx from 1 to root 3.
Okay.
It's going to be biparts, so would you have to make u the entire arctangent?
Yes, you have to, because what are the only parts there?
That and
Arctangent 1 over x?
dx.
Dx. Yeah. So either you make this dv, which makes no sense because that's the problem, right? Or you make this u. So in a sense, it's kind of nice when there's only one big ass chunk with the dx or whatever, because then you're like, obviously I make that u, because I don't know what the integral of that shit is. Now you have to remember what the derivative is, right? And I gave you, on one handout, didn't I give you the derivatives of the inverse trig stuff, right? Because I didn't make my Calc 1 students memorize it, most likely because I don't have them memorized. I never make my students memorize stuff I don't have memorized myself, right? So like the PE teacher making you run around the track, and I'm like, you can even do 1 lap, and you're making us do 20. No, so if it's something I can't do, I'm not going to make you do it.
So doing the derivative of that.
So what's the derivative of Arctane? I like this.
Theta, wait.
Just
Sorry.
let's just do arctangent theta. What's its derivative?
1 over 1.
Let's make it x.
1 plus x squared.
Yeah. That's one that I actually kind of know because it's the most commonly used one. Yeah, arctangent comes up a lot. So that's the rule, yes? When we learn a rule, great. But then, what rule takes over? So there's a rule for arctangent, and then what rule would take over? Chain rule. So you have the rule for arctangent, which says it's 1 over 1 plus the square of the stuff inside. That's the rule, right? Times the derivative of the inside. Yeah. Right, it's something that people don't quite get about chain rule. There's a rule for a function, and then chain rule is just always going, I'm here. And the minute the inside's more than, chain rule comes in. Rule for the function, chain. And by the way, do you guys all know that you always do chain rule? Chain rule is always being done, because what's the inside function here?
X of 1.
And what's the derivative of x?
1.
1. So I mean so in reality, we're always doing chain rule. It only shows up if the inside is more than x. Yeah. Okay. And that's what I mean by if the inside is linear slope 1, it should be easy. The derivative of that is 1. It's not going to mess up anything I'm trying to do, right? Maybe? Okay. So if I had arctangent of x plus 11, what's its derivative? 1 over 1 plus x plus 11 squared. Done. Because the derivative of that's 1. You know, so linear with slope 1. It should be easy. Okay, maybe. And again, I'm really sorry. If I ever say something and I'm like, it should be easy, and that's easy, I'm sorry. I try not to do that. I'm just trying to reiterate to you, if you're having trouble with it, you're probably looking at it kind of wrong. You just got to come see me. You're expecting it to be worse than it is. Something, right? I don't mean, I should be able to do it, you know, because you're like, I can't do it. So just come see me and tell me, show me what you're trying to do, right? So I appreciate that several of you guys have been to the Math Study Center. You don't have to go, but it's free. And you get help. It's crazy. Okay. Anything else from homework stuff or general questions or? Okay. So last time we finished 7.4, which was the partial fractions business. So if anybody wants to, we can do an example of that. And then I mentioned that, do you guys remember back in algebra when you learned factoring? And you learned each method of factoring, and then there's that one section that had all the forms of factoring, because that's 7.5. 7.5 has all the forms of integration that you've done up to that point. So 7.5 is a beautiful section to do as practice for a quiz or a test. I just said some magic words. What's happening Monday? Holiday. Don't come to the college. It's going to be all shut down. So let's have a quiz on Wednesday. What is that, the 20s? Is that the 22nd? Is it? Yeah, it's the 22nd. 2:22. And we'll do it on, I think the first quiz was on just up through 7.1, right? Yeah. So we'll do, yeah, let's do 7.2, 7.3. I'll give you a bit of a reprieve on partial fractions, but that's a freaking week away, so should have enough time to get into that partial fraction stuff. Okay. All right. Just for me in the future, when I go to look at this, so I remember what the hell I said. There, Jeff. It's a quiz on 7.2, 7.3. Okay. These these YouTube videos are not just for you guys. They're for me also. Like, what the hell did I say last time? Oh yeah. Okay. Anything else from homework? Okay. So let's get into. I kind of want to do things a little out of order, just to kind of give us a little bit of a breather. So we're going to hold off on 7. We'll do 7.7 next time. And if you're worried about 7.6, that's not part of our curriculum in the first place. But I do want to say one thing about section 7.6. It talks about how to use integration tables. So if you look at the very back of the book, has anybody done that? And you see all these integral tables and such, right? So, I mean, 7.6 talks about how to use those correctly. So some students get really excited when they're like, oh, I got integration tables, it tells me answers, and then they don't know how to use them correctly or where to put stuff and all that. So it's, you know, it's a whole other level of thing. And I also want to show you this. Let me see if I can do this real quick. Let me ask you guys, does anyone in here know how to do an integral, a definite integral on your calculator? Does anyone not know and would love to see it? Okay, beautiful. Not beautiful, but thank you for letting me know.
Is this part of the calculator workshop that you listed on the YouTube
No.
channel?
Yeah, we definitely didn't make it this far in the calculator. It was geared towards pre-calc and stats. Yeah.
It's on my to watch list.
Oh, good. So I don't know if anybody noticed, I did I think I sent you guys, no, maybe not. I don't think I sent it to to be honest, but I did a calculator workshop and the video's up on the up on the YouTubes, up on the
I saw
channel.
that.
So if you need that, you can take a look. Let's see. I need something. There we go. Calculator. So real quick, let's see. Let's do x. If anybody wants to play along with me, x times the square root of x squared minus 9. If I had to integrate that, what method would I use? Use up. I love it. So, what if I had to integrate that from like, I don't know, 9 to 12? Just trying to use something. No, I could do 3 to, let's just do 3 to 4. Let's say we want to integrate this from 3 to 4. Everybody with me? So watch this. I don't know if you ever noticed, if you look in the calc, the very last thing is integration. So if you hit integration, lower limit 3, upper limit 4. There's the answer. So if you didn't know about that,
You're welcome.
because now you can check your work. Now I don't know if you've noticed this about me, I like exact answers. Some people want to say exact answers, they think decimal, but that's exactly not an exact answer. A decimal, you had to stop, right? So natural log of 7 is an exact answer. Exact. 6.1734547 is not exact. Do you understand? Because it for sure keeps going forever and ever. Anybody freaked out about the way this graph looks? Let me try to get rid of that. There we go. Look at this graph. Isn't that weird? But of course, what happens when I try to plug an x in between -3 and 3? What happens? In between -3 and 3? Try to plug a 2 in there, what do you get? Complex number, right? You guys with me? So that's why everything between -3 and 3 is blank, because our calculator can't graph complex solutions, right? It'd be really neat if it could. It'd be very colorful. That's all I'll say about that. Okay. All right, John. Side note about this particular function. So yeah, you can do that with anything. And what you do is, if you have an exact answer, you plug it in your calculator, get a decimal, do it in the calculator, compare, right? And while I'm talking about this, I've noticed on several homeworks that some of you guys know about, for example, photomath, which has relatively, has anybody ever heard of photomath? And of course, now you're going to go look at it, but I don't give a shit. You're going to find out about it. It's where you just point your calculator camera at your phone camera at a problem, and it tells you the steps, and it does the problem. So they've expanded to calculus, So now I've got a few more people that are like, oh, okay. Those kind of things are awesome to check your work, right? And then of course you got old standbys like Wolfram Alpha. You've got even Reddit, subreddit, cheat at math homework or learn math, and I like to go in there sometimes and either help people or go, get this shit out of here, go do your damn work. You're a little old math teacher. Those types of things are awesome to help you. Each one of them has idiosyncrasies. Idiosyncratic? They're weird, the way that they solve some problems, and it's obvious to me. Especially photomath. Photomath is weird as shit. So when I see something in a format, I'm like, wait, I'm gonna pull up my phone, because I got photomath on my phone. I do it, I'm like, you copy this shit, get out of here. Right? So just understand that I know, right? I feel better that I'm not an English teacher right now, because you guys know about Chat GPT? Yeah? I made that thing create so many things for me, it's kind of funny, but it's going to become sentient and go, you made me do this, kill us all. But anyway, if you don't know about Chat GPT, that's a really good one to look up, just to play around with. It's kind of neat. But just be aware that I know these things exist. Now, unfortunately, there's also services that will do your homework for you, and they're done by people. That one's harder to catch. But I always love it when I have somebody that has these beautiful homework grades and they get like 40s on the test. And they try to tell me, well, look, your tests suck. I'm doing great. Get out of here. You're not doing the homework. Go away from me. Okay. So there's that.
Yeah, that's
Okay, so tonight, oh yeah, I didn't catch any of that, dang it. Tonight, I want to do actually 7-8. Just because 7-7, I just want to give us a bit of a breather. We're going to leave a little early tonight. Today was rough. I am just sort of done. But remember, I told you 7-7 brings back Riemann sums and actually makes them more interesting. So, for example, instead of rectangles, we're going to use trapezoids and even parabolic things, right, to estimate what's under a curve. You with me? Okay, so we're still going to do it, just going to do it next class, right? Tonight I want to do section 7-8, which should be comparatively nicer. And so let's see what 7-8's all about. So 7-8 does something like this. So there's an obvious new thing happening here, right? We have a integral that kind of goes forever. Right? You with me? So, dear God, if I ever see anybody do this, or this, or something, right? No. Why can't you plug infinity in somewhere? Because that's assuming you can actually go to infinity, pick it up, and put it in. And if you could do that, I want to see that. Just bring it to me, right? Put it in the briefcase. So when I open it, it's all shiny, and everybody says, "What's in the briefcase?" Another Pulp Fiction reference, I'm sorry. So, the way that you must do this is we must rewrite this as a limit. Oh, get out of there, too. So what this means is you do that integral, and the very last thing you worry about is the limit. But you don't lose the limit. You got to come with you. So let's try this one out. So I'm going to rewrite the limit. What is the integral of e to the negative x? Negative e to the negative x. And you want to evaluate from what to what? 0 to t. I love it. Because I can put t in anything. Right? I don't mean Earl Grey. I could put the t value in anything because is t ever infinity? Nope, that's the whole point of a limit. It never gets to this. So I can put t in it because what is t really? T is a big freaking number. And one time I had somebody that would not stop putting infinity into shit. And I said, put BFN in there. And just to be nice, big freaking number, right? You can't plug infinity in somewhere. Okay, I've said that enough. Help me out now. What is that? Evaluate that inside. So this would be negative e to the negative t. So minus negative, so plus. What's e to the 0? 1. Right? And then the last step of this problem is a limit problem, which should be easy for us, right? Some of you guys might get like, oh no, should not limits, but does this limit that? What happens if I let this go to infinity? This becomes e to the negative infinity. What happens to e? E to the negative t is actually 1 over e to the t, yes?
Yeah.
And what happens if the bottom is getting bigger, bigger, bigger? The whole thing goes to 0. 1. Now think about it, it's kind of neat. This integral is 1, isn't it? Isn't that neat? That's neat, okay. So that's one example of these types of integrals, these infinite integrals. Another type would be, let me just put this up here and see if you can catch what the issue is. Let's see, can I make a good one up out of nowhere? I don't know, Jeff, not today. Today was rough. Let's see, blah, 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 blah. That looks funky. There. Sure, why not? Okay, that's nice and easy. Can anyone identify an issue with this?
1/0.
Yeah. So guess what we're gonna do? Now I want to go to 0. I want to go to 0 in a very specific way. Anyone tell? The actual interval is 0 to 1. Am I ever plugging something in that's negative? So I want to approach 0 from?
The right.
The right. Yeah. It could sometimes be important, right? So now I can do this. So now what is the integral of 1 over x? I want to go from, yeah, you're right, but yeah, it's okay. These are not negative. But you're right, in general you have to put an absolute value, but I know it's not negative. From t to 1. You guys get the idea now? It's either there's an infinity explicitly in the limits, or there is a value that makes the function itself undefined or infinite. So the way we do this, the way we always do the shit when there's a weird place, we do the limit. I don't want to go to the weird place because I don't know what's going to happen to me. I want to get really close to it and go, where's it? You know, get really close and don't touch it. So when I teach limits, I remember the old sci-fi movie, The Blob, right? So the thing will crash lands and the guy comes up and he actually touches it. I'm like, no, you do a limit. You go, what is that? And then you walk back and get really close to it. Just don't touch it, right? Do a limit. Don't actually get there, because then it crawls on you and everything, the whole movie happens. I'm sorry. So what do I get? Natural log of 1 is 0 minus natural log of t, limit. And of course, what does this do as the input goes to 0 from above?
Negative infinity.
Goes to negative infinity. So again, limits are much easier if you know the shape of the graphs of things, right? Natural log looks like this. So as I approach 0 from the right, it goes to negative infinity. So what is this? What's the answer then?
Positive.
Good. 0 minus negative infinity, positive infinity. All right, John. So this is not a very complex idea, but it is bringing back limits, which sometimes drives us a little crazy. So let me give you this. One side's got 7, 7. We'll talk about it next time. The other side's 7, 8. There's 2 problems at the bottom I want you guys to work on. And this row is spread out, which is fine. Should row the other ones. So I want you to look at the 7, 8 side, improper integrals. I give you 2 examples to kind of look at, and go ahead and try the ones I give you there at the bottom.
Because if it's 2, then you multiply the other 2.
Oh, I got negative 1 before. I had to. Wait,
So I think you went right, negative 1.
wait, if it was 2, then you would multiply the other 2. What do you?
Stretching, or are you asking a question?
But
You got it? Okay.
this turned into 0.
No, I'm a lost cause.
No.
Apparently I did. you remember how
Well,
you
you're
had
not a lost cause. All right.
Low-key,
So there's two different ways to kind of set this one up.
we're about
yeah.
I kind of much rather wrap the negative inside the t. So let's see. So then it really doesn't matter, to be honest. Right? You can either say t go to infinity and this would be negative t, or you can say t go to negative infinity, so this would be t. Right? Doesn't matter. Okay. Now what's that integral? Now you could do a u sub, but you really don't need to. It's basically 1 over x cubed. Right?
Is it so negative?
Oh, that's
So it'll be 1 over 2x minus 1 squared, right? And then you have to divide by.
6 or 4?
So let's do this. What's that? Okay. Let me change this to be. There. So I'm going to integrate this. I get 2x minus 1 to the negative 2 divided by negative 2 divided by another 2, right?
Yeah.
Is everybody with me? Or you could do u sub, but and again, if you had to do u sub there, you're fine. There's nothing wrong with that. It's just another little place where you can make a simple mistake. Now there, that's also a place where you can make a mistake. I understand, but so that negative 2 is because of the rule of anything raised to a constant power. Is how it integrates. That 2 is there to kill the 2 that wants to come out because of this guy, right? So then I get let's kind of clean this up a little bit. Negative 1/4 2x minus 1 squared. Oops. T to 0. Okay, let me stop for a minute. So then you get the limit, t goes to negative infinity. There's 0 in, that's nice. Negative 1 squared is 1, so you get negative 1/4. Right? And then it'll be plus negative, so it'll be, I'm sorry, minus a negative, which is plus 1 over 4, 2t minus 1 squared. So if I let t go to negative infinity doubled minus 1 is still negative infinity. Squared is infinity. All that crap doesn't matter because it's going to go to 0.
Shit, I think you were right. Kind of.
Wait, sorry, can you explain how you brought an extra 2 on the bottom? Is that because the derivative of the nearest 2?
Real quick, the integral of something to the negative 3 is to the negative 2 divided by the new power.
Yeah.
Then I need to divide by 2 because there would be a 2 that would come out
Yeah,
for change.
okay.
Yeah.
I missed that one.
But again, you could use u sub on that. So I know several of you guys got to that point, so. Any questions about any step up there? It's okay if you have a question about a step, it's fine. Right? If you have a question, trust me, at least 12 other people have the same question. Just all being quiet. Yes?
I heard my t going to 0. Is that okay instead of infinity?
Well, you have to, limits exist in order for us to investigate a value that makes something freak out. That's like a really highly untechnical way to look at a limit, but that's essentially what they exist for. Do you guys kind of agree with me? Isn't that what we use limits for? We use a limit to kind of investigate some area that I can't even plug it in. I can't, so I need to get close to it. You know, you did all those tables of 1.9, 1.99. Remember those? 1.999, right? And she's just like, more nines. Okay. Zero doesn't do shit to this. What do I get when I plug a zero into this function? I get -1. Do you see that?
Yeah.
If I plug a zero in, it doesn't freak out at all. Everything's great. I get a number. If I try to plug infinity in, I can't do that. I can't plug infinity in, right? Does that make sense? So will there ever be a time when you let t go to 0? Sure. If 0 makes the function that you're working with freak out somehow, it's undefined, infinite, something. In this case, that's the issue. Okay. Anything else about this? All right. You guys always look so beat up. I'm sorry. Ask me anything about this. Okay. What about this guy? We already talked about what your limit's got to be, right? Limit as t goes to 5 or 6. So 0 to t. In order to do this integral, what do you always try first if it isn't like an automatic, like integral of secant squared? You don't have to do shit to that. What do you try first? U sub. And of course, there's a lot of kind of flexibility with U sub, but what's the most fundamental thing you try to let U equal first is the most stuck piece, right? The most inner piece. And you know, there's variations to that, and there's other things it could do, and blah, 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 but that's like the most classical, traditional U sub, is 1 minus 2 sine x is so freaking stuck. It's inside a root, which is underneath something. Holy shit, it is stuck. So let U equal it. And if that doesn't work, then we try something else. But what's du?
-2 cosine x.
Coolness. For some reason, several people had trouble with that -2. The coefficients just come for the ride, right? They just come for the ride. They're like, -2 times, do your thing. I'll be here. So the way I do things, which I know is different from some of you guys, I want a -2 here, so I can find my du. So I put a -1/2 outside to balance it. That way I can just see where things are coming from. They don't just pop into existence. But if you do it the other way, it's fine. So I get -1/2. So this will be du. This will be u to the -1/2, 11. Now I didn't change these. I'm just going to do this now. Some of you guys did change them. You could change those, right? But I don't know. I probably should change them, but I didn't. And of course, the integral of u to the -1/2. Yeah, u to the +1/2 divided by the new power. Yeah, so these cancel. That's kind of nice. Evaluated from 0 to t. Okay, I'm going to stop for a minute. So it's just one step at a time. And now I can bring back what u is. What the hell is it? It's -1 minus 2 sine x to the 1/2 from 0 to t. Oh my god. So then you get limit. T goes to pi over 6. -1 minus 2 sine t minus -1 minus twice sine 0. Square root, sorry. Leave out the square root. So if you let t go to pi over 6, 1/2 of 2 is 1, 1 minus 1 is 0, so that whole thing is 0. It's bodacious. So real quick, notice something. Real quick, you guys help me out. What's the domain of square root of x?
0 to...
Do I include 0?
No.
Yes, because what's the square root of 0?
0.
Alright, everybody with me? So the domain of square root of x is bracket 0, comma, infinity, yes? What's the derivative of the square root of x? 1/2 root x. What's that guy's domain? Can I use 0 in it?
Oh, no.
No! Now it's parentheses 0 type thing, right? What the shit am I talking about? Didn't the original problem have the original integral had a problem at pi over 6 because the radical part is 0 and it's on the bottom. But after I integrate it, it's on the top now. Do you guys kind of see that? That's why those radical problems are a prime classical example of this thing. This is undefined at pi over 6. So on first glance, you're like, it goes to infinity there. How could the area be anything? But the minute you do the integral, it becomes a function that's completely fine there. In fact, that piece is freaking 0. So I'm going to plug a t in, and I'll let t go to pi over 6. So this will be negative 1 minus 2 sine t. Did I do it over here? You did, yeah. There you go. So this goes to 0. And what's this?
0.
Is it? What sign is 0?
0.
So 1 minus 0?
1.
So the 1/2? 1. Okay. Weird. Another integral whose answers 1. Right? That's neat. I don't know if past Jeff did that on purpose, but maybe. All right, how you guys feeling about that? That's relatively not that bad. Do you guys agree with me? I mean, relative to some other stuff we've done, right? Limits, normally you have trouble with limits, but that's not really asking too much, these limits. Now, the unfortunate thing I want you to realize is this step here could be any method, yes? Sorry. So, once you do your limit t thing, what you have here could be a trig sub, it could be a u sub, it could be a by parts, it could be a whatever, it could be whatever I feel like doing. I normally don't make it too much because there's already a lot to kind of keep track of the freaking limit. I understand that, so. Okay. Let me show, I promised I would show you an example with the problem at both limits. Is everybody cool with what's happened so far? Any questions? Okay. Cool might be too strong of a word, but okay. So what about what do you got, Jeff? Let's do do they even do one? Wait a minute. Maybe I don't have to worry about it. Hold on. One moment. All right. Shoot. All right. Maybe that's too much. Okay. I don't want to do more than they want you to be able to do. Interesting. Bum, 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 bum. There it is. Okay, sweet. Okay. Too bad for you guys. All right. Just want to make sure they actually do this to you. This is a little bit evil, but oh well. You guys have your handouts. This came up earlier today, right? Okay. So how the shit are we going to do this? Who's got a suggestion on how to do this?
Isn't that like a trig identity?
All right, don't start thinking about the integral because we have an issue before we can even think about the integral, right? The limits themselves. So believe it or not, we have to do this first. Now I'm just going to leave this blank. Become an infinity. we have to kind of break it up into two pieces, right? And you guys remember if there was an issue at a place, you would break the interval up? Maybe you're supposed to go from 0 to 6, so go from 0 to 1, and then 1 to 6. Do you guys remember? You would break the interval up. Do you guys remember doing that? Or when you had to find the area between two curves, and the top one became the bottom one, so forth, so you had to kind of break the interval up. Do you guys remember that? Okay. So here, with this approach, with the limit approach, we can only handle one limit having a problem at a time. So we have to first break it up. And I can break it up to be any number, because what's in between negative infinity and infinity? Every number. Okay. All the real numbers. So not surprisingly, I'm gonna choose 0. Because I can choose whatever I want. And it would be true. Do you guys agree? Okay. Oh man. So this first one, how would I rewrite it?
Limit as t goes to negative infinity, interval t to 0, 1/1 plus x squared dx.
Take gas. So now the limit as t goes to infinity. Now this interval came up earlier, right? So what is the interval of 1/1 plus x squared? Arctangent. I prefer to write like this. Arctangent x from to 0 plus the limit t goes to infinity. Arctangent x from 0 to t. Okay. Okay, so then we got limit t goes to negative infinity of arctangent of 0 minus arctangent of t plus the limit t goes to infinity arctangent t minus arctangent of, what was it? Anybody know what the arctangent of 0 is? So arc trig is asking you what angle makes the output of the trig function 0. So in this case, or whatever the inside. So this is saying when is tangent 0? 0. Because tangent goes like sine. Because what's on top of tangent? Sine. So whenever sine is 0, tangent 0. So this is 0. And what the shit is this?
Negative pi over 2.
Beautiful. So again, what's going to save your ass is knowing what these things look like. So can somebody tell me the innermost trig graph of tangent? So I don't need all the iterations of the repeated wavelengths and such.
0, negative pi over 2,
Yeah,
pi over 2.
negative pi over 2 to pi over 2. And then it looks sort of cubish, right? Yeah.
Arctangent is on its side.
So all arctangent does is it's an inverse function. So it's just going to flip it over the y equals x line. So everything that was x now becomes y, and vice versa. So these asymptotes just go here. So now this thing lives in here. So this is tangent. This is arctangent. And of course, why do we have to restrict the domain to be this? Because if I repeated it, it would not be invertible because it wouldn't pass the Holt, the ham, lettuce, tomato. I mean the horizontal line test. Okay, I like it. It's just for me. So what is the arctangent of negative infinity? Or what's arctangent doing as its input gets closer to negative? It's really, really big negative. Going to negative pi over 2. Plus, so what's the limit of arctangent as this input gets really, really big? Pi over 2. And of course the arctangent is 0, 0. So then you get half of pi plus half of pi is a whole pi. Neato. Kind of funkadelic that, look at this equation. Just look at it by itself. Is there anything trig in there? I mean, would you ever expect the integral of this very simple function from negative infinity to infinity to be pi? No, I wouldn't expect it. No. But there it is. It's crazy. It's some funky shit. Okay. Pi comes up in the weirdest places. Okay. Ooh. Interesting. Okay. Let's do this. This will be the last thing we do tonight, I think. But it does set up something for the future.
Can I go for a minute? Writing this down.
Yeah, go for it. Here, you guys. Let me make sure I got this right. Bum bum ba da bum. So I want to investigate that. That's a P, yes. So it's a constant. So let me write it over here. What's the one power in there that actually causes this to not follow a general rule? You guys know this. What's the power? Because how do you integrate x to a power? How do you integrate x to the n? What's the integral of x to the n? X to the n plus 1 over n plus 1. What's the only value of n that makes that freak out? The only value is negative 1 for x to the n. So here, if p is the power of 1, so if p equals 1, right? What would that integral be? So let me write it with the obvious thing we need here, right? So if p equals 1, this integral is going to be, say it again, sorry? Natural log of x, I like it, evaluated between 1 and t. And what happens when you let the input go to infinity? No, goes to infinity. Minus 0, right? Is that cool? All right, so that's not interesting. I want to know what values of p allow this to become a finite number. And when something like this becomes a finite number, we like to say that it converges. So this is divergent. Become a V. This diverges. I'm curious, what values of p allow this to converge, to become a finite number, right? So if p is not 1, what would this integral be? Let me write it a little bit better. So assuming that p is not 1, what's this integral? If p is not 1, I could just use the rule, right? How do I integrate x to any power? X to the, let me put my limit down. X to the, what happens? What's the integral of x squared?
X cubed over.
Oh, okay, so what happens all the time? X to a power. What happens to the power? Add 1.
Over p plus
Divided by the new power, yes?
Yes.
11. From 1 to t. So this becomes the limit as t goes to infinity, t to the negative p plus 1 over negative p plus 1 minus 1 to the negative p plus 1 over negative p, which is just 1 over negative p plus 1. Now listen, p is just a number, so this little dude is just a number. It's just a finite number, right? Yes? So p is just some constant number. You guys with me? So this piece, I don't care. I'm curious, when is this piece not blow up? What values of p? We already know at 1, when p is 1, this thing goes to infinity. We knew that. In fact, if p is 1, doesn't the bottom here become 0? Right? If p is less than 1, what is negative p plus 1 if p is less than 1? You can do it. You can do it. If p is less than 1, what is negative p plus 1? What kind of number is it? Give me a number less than 1. 1/2. What's negative 1/2 plus 1? 1/2. Give me another number less than 1. Negative 1, right? Negative 1 plus 1 is 2. Yes? So forth. So if p is less than 1, this thing is going to become either fractional or positive power. Isn't this going to go to infinity then? I need you guys. What's the only time this is not going to go to infinity is if this power ends up negative. If I have t to a negative power, right? If the power stays negative, then that's going to be 1 over t. It's going to go to 0. It's going to converge. It's going to be whatever the hell this is, right? So p, in order for this to converge, p has to be greater than 1. It's the only way to make this power negative. Give me a number bigger than 1. 2. It's negative 2 plus 1? Negative, right? So would it become 1 over t? And when I plug an infinity in, then that's 0? That would converge, right? So if I have a value of p that makes this 0 or positive, this is going to diverge. It's going to become infinity. So only if p is greater than 1 will this converge. Yes?
I'm sorry, what do you mean by converge and diverge?
Converge means become finite. Diverge means to go to infinity, or to at least not become some finite number. Yeah. So this idea of divergence, convergence is going to be huge in chapter 11. And we're actually going to see this guy make a huge comeback, right? He's going to become a very, very important little dude. So I really want this to make sense. If I'm going to make this go really, really big, if the power is positive, doesn't it stay really, really big? So that's going to go to infinity. If the power is negative, isn't that going to make it 1 over really, really big? Makes it go to 0. So then it would converge to this. It would become that finite number. That would be the answer. And the only way to do that is p greater than 1. That's what makes this power negative, which makes the infinity go on the bottom. Okay, that's enough. Okay, that's plenty. All right, so that was a little taste of what's to come in chapter 11. So next time we have the quiz, and then we'll do section 7.7. So we'll go back and do that section next time. Let me see. Ali and Naya? Yeah? Samantha, Johnny, Owen, Amani I think is out. Yeah.